Hello, everybody. Welcome back. Again, welcome back to the HowTube audience. Thank you for hanging in there with us. We have the great pleasure of welcoming George Howard. And he has a website called Cosmic Tusk.
That's
is that
right.
Correct? And is that a podcast as well, or?
No. Sometimes I'm a guest on them.
Okay. So if you want to find out more information about George Howard, just go to cosmictusk.com.
That's right.
And
easy to Google. No other known use of the term Cosmic Tusk on the internet.
Yeah. So I'll leave it to George. George is ready to go. Let's save the Q&A for later, and we're all ready, guys.
Hey, still morning? Good morning and happy Easter, everybody. Yeah. Isn't it neat? You know, it's Easter, and that's death and resurrection and change and transformation and paradigm switching and, you know, kind of all that. And here we are on Easter talking about those same things. But what we're going to talk about today is the death. You know, there's a whole other story at the end of Younger Dryas that Graham gets into pretty well when we came back out of it. That was kind of the rebirth of the earth. But it had to die. So I've got the task of showing you the evidence that it was killed, right? That it was shot. And I do some public speaking, but I never speak on the Younger Dryas event other than podcasts. I haven't given a presentation on it in maybe 10 years, which is kind of sad to say. It should be more interesting, but I haven't. And I think I'd love to do the way that Randall does it, where you have 50 slides and you just kind of iteratively pick those that seem to match what you want to talk about. And I hope to do that one day. But I've got a linear presentation, okay? With a bunch of animations in it that look like, you know, like it's the best PowerPoint made in 2011, you know? And it is kind of a stock thing that I helped work on years ago, and then we updated it a little for this. And we're just going to walk you through the forensic evidence, not really the story of the discovery, although I'll probably elaborate on that and whatnot. But first, I kind of wanted to tell you kind of how I got into this, just for the hell of it. I was a science geek as a kid, did very poorly in school. I certainly wasn't going to be a credentialed scientist. And then I kind of put the science stuff behind me, you know, because I got into politics and I worked in the U.S. Senate for 6 years. And it was very intense, working in the actual Senate offices, you know, big bosses, busy Capitol, all politics. And I didn't handle like telecommunications or defense or any of the big issues. I was the wetlands guy in the U.S. Senate. Believe it or not, there's a body of law that regulates wetlands, and they were trying to reform it at the time, and I was in charge of that. So I learned a whole hell of a lot about wetlands, you know, from a policy standpoint. You'd always see lists of types of wetlands, and it'd say marshes, bogs, fens, swamps, bunch of different names like Carolina bays. I said, what the hell is that? That's kind of funny, because it was used in national, you know, publications and whatnot. They weren't talking about the Carolinas, but it had its own special kind of wetland in North Carolina called Carolina Bays. And I was like, it sounded like it was a marina or something. I had no idea what it was. And one day my boss, who's a farmer, very large farmer, but he was kind of a rough country man. Very, very smart man, but he was a country guy. He was Locke Faircloth. Wonderful man, taught me a lot. And in his classic way, he said, get me a map of my farm. And I was like, yeah, I know you own 40,000 acres in Sampson County, you know. What kind of map? He goes, 1 to 22,000, you know, USGS topo quad, which I really had no idea. I actually work with them frequently now, but I had no idea what that was, you know. And I'm like, USGS, I'll go figure it out. I'll call up the USGS people. And he called up USGS congressional liaison. I said, could I get a map of Sampson County, North Carolina? And he said, it's some 1 to 24,000. And they said, sure can. We'll send it right over. They bring a courier, brought a tube, had a map, the proper topo quad. I said, Senator, I got your map. We rolled it out on his desk, and he was looking at something else. I started looking over his shoulder. I said, what the hell are all of those ellipses on your farm? Because USGS marks it in map form. It's not LiDAR and that kind of stuff where you're showing elevation. It's just, you know, they have various ways to represent things. And they had perfectly dotted lines all over his farm. I said, what is that, Senator? He said, meteor holes. I was like, and then the scientist came out at me, yeah? I was like, meteor holes? You mean craters? He goes, oh yeah, it was a big deal when I was a boy. I said, what? He said, damn, something came in, a comet, blew up and just fucked everything. He cussed a lot. Just wiped out all eastern North Carolina. He said his Evening Life magazine. I said, you know what? I'm kind of a statriot. I thought I knew every damn thing you could know about this state, and particularly kind of sciencey stuff. Really? And he goes, yeah, they call them Carolina Bays now. And I was like, that's what the hell that is. And I was hooked. I went straight back to the computer. The internet had just come out, and I was the first person to actually get hooked up in the office. It's about 94, and I Googled it, found a great friend of mine, friend of this day, Bob Cobras. Some of y'all may have heard of. Found Randall.
We interviewed Bob for the 1996 Fire from the Sky.
Yeah, great guy, very intelligent.
Way ahead of his time.
So I became fascinated with Carolina Bays. This is way too long of an intro, but I mean, truly fascinated. And within a year or two, I moved home, and that was great because I had access to the library at UNC, went and read Henry Savage's book, drove out and saw him, you know, and all this stuff. And I had a buddy that had gone back to college. You know, he never quite finished when we did 8 years earlier. He went back to college. He was trying to touch up those last classes, and he took geology. And he said, you know what? They gave us subjects to write papers on, and one of them was that crazy shit you're always talking about, the Carolina Bays. And I said, yeah, that's my thing. He said, hey man, could you write me some notes out on it? Because we got a paper due. I was like, yeah, I'll write you some notes. Never wanted to write a college paper in my life. And I said, I'll actually write it down. I wrote a 27-page paper for my man. He got a B. He should have gotten an A because it was a well-written paper, but I think there was a little bias, you know, in the professor's part, but he did give him a B. I'm like, what the hell am I going to do with this paper? It can't be just it. And the internet was out, and this is embarrassing to say, but I actually opened up georgehoward.com. It's pre-Facebook, kind of wanted to have my own website. And it had a little bit of stuff up there, and ended up with a whole bunch of stuff about the catastrophe. But I hoisted that paper up there. So that's a good thing. It'll pop up in people's searches if they're interested in Carolina Bays. And to this day, it's one of the top hits. Might have been downranked now, but people fall into the rabbit hole through reading that paper. And one gentleman started contacting me named William Topping. And Topping is the first name on the bibliography list for anything about the modern Younger Dryas Impact hypothesis. And he was kind of a nut, to be frank. And that's all on the internet. He was a character, okay, and kind of paranoid and whatnot. And I think ultimately got raided by the FBI for something, but he was also a truth, and he was an archaeologist in Michigan. He had an archaeological site called Gainey, and we'll see that. And he contacted me, and it was just kind of weird communications. I didn't really think he was on the thing, and said he was finding evidence that something had blown up over the Midwest. And he was finding these spherules, and he was finding certain, you know, suggestive things in the soils. And he said, and I found your paper, and you think that too? Something blew up over the Midwest. I said, well, a lot of people have. Anybody that's ever studied Carolina Bays that takes the extraterrestrial hypothesis thinks that something blew up. And he said, yeah, and we kind of worked on it, but I kind of thought he was a nut. And then I get an email from Dr. Richard Firestone. It said, I'm working with William Topping, and I'm looking over his evidence, and I'm very interested in it, and I wanted to collaborate and talk Carolina Bays with you. And his address said 1 Cyclotron Drive, Berkeley, California. So I went from what seemed kind of like a fringy nut guy, you know, and I was like, holy cow, this is a real scientist here. And he said, we're writing a paper on what we believe was a horrific catastrophe 13,000 years ago. We were surprised to find that you detailed in your paper that people had been thinking in the Southeast, or whoever was studying the features in the Southeast, that they suggested that there was a tremendous catastrophe, and many people think it's 13,000 years ago, and we're finding a whole nother line of evidence that has absolutely nothing to do with Carolina Bays. So that's always interesting in science, where people get to the same place through different sets of evidence. And then ensued a whole long thing. You know, I was buddies with them, and in 2015, I got contacted by Dr. West and Dr. Kennett and Dr. Bunch, the leading lights of what became a team to go take that original Firestone topping paper in 2001. They did write a paper, but they had some major flaws on it, and they probably had some interpretations that weren't ideal. And so it didn't go very far. But they said, we want to tune this hypothesis up and really publish it. So that's 2015. And I've talked to Alan and those guys every day. I was so fascinated. It was so great because I'd been consumed by it for years. And here were some real scientists that are putting it together. So I'm going to show you the evidence that those scientists have put together and allowed me to join as, you know, a pajama scientist, you know, a civilian, which has been one of the greatest blessings of my life. So why is it important? What's interesting about the Younger Dryas hypothesis? There are a lot of them. I could have 20 bullets on here. But in essence, you know, it solves these mysteries that science has accepted for 50 years or more, right? That it's almost become part of the story of the sciences, that it's just a mystery. And those mysteries are what in the world happened to the Clovis people? Who's heard of the Clovis people? Just do a quick, yeah, okay, good, I don't have to go through that. Okay, so what happened to them? There's a lot of interest in their life ways and their tools and all that kind of stuff, but what the hell happened to them? They were pretty successful. Why'd they disappear? What happened to all those cool giant mammals? 250 species, 52 genera of animals went extinct within, you know, a geologically instantaneous time. And we'll see some graphs later that show you see them trail off. They didn't get vaporized all at once, and some people say we think that, we don't believe that. But we believe this impact may have caused that. What caused the flood, both mythical and actual? Right? We know there were actual giant floods beyond comprehension, and we know that every freaking culture in the world says there was a catastrophe. Okay, so maybe we got the answer to that. That'd be cool. And why did humanity, why did Homo sapiens change so dramatically at the Pleistocene-Holocene transition? It was a turning point for us. And we were interesting people back then. I think we're kind of interesting people now, but we're different people. We had them. We went from plucking pears to pulling plows. Not immediately, but that's when that transition began. So what's our hypothesis? It's that there was an extraterrestrial impact event, has nothing to do with aliens, occurred 12,900 years ago, that it consisted of thousands of air bursts across the north and southern hemisphere. We're going to concentrate on the northern hemisphere today, and even kind of a limited part of it. That it displays debris, we call them proxies, things you can find that indicate what happened, so they're called impact proxies. That it released cubic kilometers of meltwater, which, you know, Randall has famously described. That it halted the Gulf Stream. Now remember, that's mainstream science, and there's a weird division where the Younger Dryas event has very well accepted components to it, right? And we say it halted the Gulf Stream. Had we said that, that would sound crazy. But that was already a published fact. I mean, that's totally accepted by the mainstream. What they don't tell you is, you say, well, why did it halt? They said a bunch of fresh water came in. Well, where'd the fresh water come from? Big lake in Canada. Well, what the hell made the lake go? And they're like, It's a mystery. It's a mystery. And we're just going to tolerate it forever, and don't give us any crazy answers. Okay? That initiated the Younger Dryas cooling. We believe that it caused that dramatic cold period we'll describe more, that it contributed to the megafaunal extinction that triggered the collapse of the Clovis culture. That's our hypothesis. The evidence, we found it at 40 sites in 12 countries on 4 continents. California to Germany, and actually to Syria now. This little legacy slide. 25% of the northern hemisphere, and we found no boundaries yet. You know, this is all kind of done on a shoestring. You know, if we had a big $1 million National Science Foundation grant, which wouldn't even be that big for National Science Foundation, we could go test in China and Africa, and we've actually found some evidence in Africa for other but the team has been limited. But we've never found a place, an appropriate place, that you could not find the evidence. So in North America, particularly the United States, there's that Gainey, Michigan site. That's where William Topping first found the evidence. Then you go over to, that's how you go back. Okay. Not particularly important, but these were all Clovis sites that had been well dated by the mainstream. And that was the hack of the Comet Research Group. The hack was, let's go to places where they can't dispute the dates if we draw something out of the strata, because they've been publishing on it for 40 years, that at this site, it is 13,000 years old right here. So the hack is to go look at those sites. So we started looking around the country, all of them, again, famous paleo sites. Oh, come on. Don't want to start this part. Okay. Including iconic Murray Springs here in Arizona, the Leonard site down the road. Also iconic Blackwater Draw. Topper in South Carolina, which is Al Goodyear, who's on our team, his site, which is a 2-hour mind-blowing presentation on its own. And the Kooky Caboose, the Carolina Bays, which is a whole nother kettle of fish, okay? So it was in the first paper the bays were, and then we dropped it off, because if you're trying to prove something, you use your best evidence in court. It's not the best evidence. It's just the most interesting damn evidence. And then we found it all the way over to Germany, Belgium, and the Netherlands. And Chris back there saw all over my shoulder that I had this slide. He said, there's evidence in the Netherlands? And I said, yeah, mate. He goes, really? I said, God, there's some of the best evidence in the world, the Oslo Horizon, that in the European cover sands in Northern Europe, at huge locations, you dig right down. It's easy to dig. It's just sand. It's one color. There's a black boundary, and it's another color after that. So let's talk about Murray Springs. Again, kind of an iconic campsite. Anybody that's studying this in any university is going to where they start there in Blackwater Draw. And a mammoth kill site, and that's important. So the people both live there, and they know they were butchering animals, and all of this is in situ. It's still sitting as it was left, right? So what do we find there? You find the black mat, the coolest geophysical phenomena in the world. And that's analogous to the KT boundary. Remember this, the KT boundary is what that would be if you waited 65 million years. It'd be rock, right? So the KT boundary, you're crushing rock and testing for this stuff, right? This is still sediment. It's only 13,000 years old, right? What else do we find? Mammoth at that site, mammoth, camel, and horse. But you find Clovis artifacts. And you find our evidence. But here's the key thing. At no black mat site or Clovis site that we've tested, or actually that doesn't have anything to do with the Younger Dryas, even if you took the impact out, at no site that they've ever investigated and done digs on, do you ever find any of this material above the black mat. And oftentimes you begin finding it immediately below. And one of kind of the casual hacks of a paleoarchaeologist is, some of them that were really in the know, they knew when they were digging, when they found that black mat, they were going to start finding points. But nobody ever went and looked, what the hell is the black mat? Really looked at it. And that's what the Comet Research Group did starting in 2015 and then published, 2005 and published in 2017. And what they did, I was involved, but I didn't collect the stuff. But you go out and you sample above and below the black mat, and it's important. There are two different things that people confuse, totally justifiably confuse, that are kind of in the know about this stuff. The black mat and the YDB layer, the Younger Dryas layer, are different things. The black mat is not where the material necessarily is. They find the anomalous materials that suggest a cosmic impact are found immediately below it. And then the black mat is the wasteland. That's the signature of the horrific wasteland that was wet, dark, algal, right? And just kind of disgusting for 1,000 years. So you find the stuff directly under that. Let's talk a little bit. So you get your black mat, and holy shit, they found a mammoth. a whole articulated mammoth called Eloise, they named it. And this is back in the 60s. So this is long before Alvarez or anything. If anybody was sitting out and said, seems like something might have blown up and killed all this stuff, you know, they tell them shut the hell up. And Eloise's bones are stained by the black mat. Now this is interesting and kind of timely. Some of you may have caught the reports, worldwide news, a couple of weeks ago about the KT boundary, where they found the actual remains of dinosaurs that apparently had been just like this, in total contact. And it's theoretically possible, but was never expected to happen, that you would find the last dinosaur, a dinosaur that actually experienced the impact. And those were the claims made a couple weeks ago, which is a little galling to us because we got a more recent one right here, you know, and it's not worldwide news. But again, all the artifacts and the bones are never above the black mat and just below it. So that is in the extinction layer. And the impact markers cover the bones just below the mat. So you got the mat, the impact markers, and then you would have bones. And the question is, it was one of the last mammoths. Was it killed by the impact? Probably not, because I think it was, certain it was associated with Clovis points. It was a butchered animal. But a butchered animal generally becomes disarticulated later. Its bones get separated and stuff. This thing was found in the butchered condition. So the damn thing was probably butchered, laying there in some form of prep or whatnot, and then they had that really bad day, right? Okay, how do we test for this stuff? It's actually pretty damn simple to get the material. It's a whole different thing to go and look at it in transmission electron microscopes and, you know, find diffraction patterns for diamonds and all that. It's very complicated. None of us could do it, but anybody can do this. It's totally legit. But you take a neodymium magnet. They used to be really expensive, but now they're dirt cheap, and they're super powerful. You know, you don't want to hit your belt buckle or, you know, grab your phone or anything like that. You put it inside a plastic bag, and you pass it up and down the strata and record where you are, right? Don't do it casually. And then that produces at least the iron fraction magnetic particles in there. And you're going to end up with just some pieces of iron that are of no particular interest. About the vast majority of it might be, right? But what you want to do is literally sift down through that and see what you find. And you find magnetic spherules. These are very special little balls, right? They're smaller than a speck of dust. You can get, I think, a whole lot smaller than a speck of dust. And then you want to take a real close look at them. And they have. There has been hundreds and hundreds and hundreds of hours put in by our team at NC State and Raleigh, and I go over there, I look over their shoulder sometimes, but I have no idea how to operate the machine, you know, and whatnot. But they go and fraction all that stuff down and then take that little magnetic dust and take a close look at it. And it's enriched in certain things that suggest impacts. It's also in mostly the actual soil and magnetic fraction of the soil. So again, think if you have an air burst, right, or even a crater forming event, it's gonna, but let's talk air burst, because most of this was probably air burst, that you're gonna have ablation of the actual object itself, which we believe are comet fragments, and ablation means it's coming through and it's shedding off stuff at hypervelocity, high heat, and a lot of that stuff, at least the parts that have iron in it, are gonna vaporize, and then that vapor is gonna freeze, essentially, and then it's gonna form as a spherule, and it's gonna be fallout, right? It's also gonna be mixed with, and generally is in our belief, material from the ground. So you go, whoo, hell comes down. Hell's mixed with some metals that are already melting, kicks up other stuff from the ground, all of it goes up big vapor plume, high heat, whatnot, shock wave, and then it all falls back down. I'm not 100% sure, I just put this one in this morning, but we even find them, I was desperately looking for the perfect ones, where the little tiny spherules in the process where one was formed and another was a little more solid, it'll hit another one and make a crater on it. So talk about scaling. Something scaling, that a crater-making event with a huge impacting object can then produce evidence where it's making crater events of little tiny stuff. Carbon spherules, that's kind of like if you took this heat, this is 3,500 degrees centigrade, melt a car into just a pool of liquid instantly when you put in that kind of heat. So you apply that kind of heat to all the carbon in our environment, all the organic stuff, and it's going to vaporize it, and it's going to form into little spherules as well, right? And those little spherules are kind of unique. They disputed them. They said it was bug poop. One of the papers, the critics said, bug poop. I think they even had it in the headline. It was all in all the newspaper headlines. Comet turns into bug poop. If you think these scientists could look through a transmission fucking electron microscope on their own dime for hours and hours at a time and not miss that they've got, what do you call it, sclerata or sclerota, whatever, bug crap, instead of an anomalous carbon materials, they're calling us just idiots and frauds, just right there, because you can distinguish that stuff. So they have a certain way about them that's cool. And they're also, these gas-formed vesicular nature to it, right? We're in that turbulent hell of gas and carbon material. When it comes back together, it has voids that just show that it was all very quick, very dynamic, very hot. Then you find glass-like carbon. Joe talks about this a lot, and he's finally calling it trinitite instead of tritonite. And for those in the know, and who the hell cares whether he says it wrong, but if you're one of the geeks on this stuff, you're like, tritonite, no, it's trinitite. You did. No, I cheered you, Randall. You did correct him. He didn't just pop up saying it right. You got him right. So it's trinitite. So some of that molten hell freezes back into actual little pieces of glass in the intense firestorms. So the whitey bead layer, not the black mat, placed under it, the Younger Dryas boundary layer contains surprising things, but trillions of nanodiamonds were the biggest surprise. Now this is not regular lab work. It is very, very difficult to characterize diamonds at that super small scale. And you do it by looking at the refraction patterns, I believe did I take one up? Yeah. So you really got to know this stuff, which I certainly don't, although I've spent some hours looking at it. We actually got a patent on how to form diamonds using this process, me and Alan West. And so I learned a little bit about that through that. And they were absolutely everywhere, okay? And they were discovered later, right before we published the 2007 paper. So I think we only had one site in there and kind of qualified ourselves. But then after the publication of the paper, it was the best line of evidence. So a lot of work went into the nanodiamonds. And then whole papers were published just on the nanodiamonds because they're unequivocal fucking evidence that something happened and you didn't want to be around that day, right? Something that can produce a diamond, we all know, is, high pressure, high heat. We think it has a lot to do with the anoxic environment, that you don't have oxygen in these plumes of hell. And that combination has a lot to do with why the nanodiamonds form, and that was part of our patent. So yeah, you got these nanodiamonds. Alan West is going to tell us more about them later this afternoon, so we'll go light on nanodiamonds a little bit. But we found them up there in the carbon spherules, so they're actually embedded in the spherules. And then we also found them in the sediments, actually loose in the sediments at those paleo sites. Okay, so how do you present this stuff? You've got these materials. How are you going to make the argument that they're special to be at this location? Remember, you went to well-dated sites. Murray Springs, dozens of papers reaching back, decades, that knows that that place right there, however many centimeters of depth it is, 40 centimeters? I don't know, that seems a little strange, but that at that location, they know it's 13,000 years. That's also where the black mat is, so let's go ahead and graph these materials I've been discussing, and where do they occur? Did we see any of that material below? So here you got magnetic spherules, grains, iridium, and their peaks, and they all peak right there. Not above and not below, right? Same thing in Shabbat, which I believe in Canada, right here in Arizona, Murray Springs, and Topper in South Carolina. We think in the southeast it didn't turn into an algal mat wasteland, so you don't see at Topper the black mat. But you do find the materials, right? So no algal mat, wetland, wasteland horror show. It was probably a horror show, but it just didn't show up as a mat. So it was very gratifying, you know, and to find it where Al Goodyear did know that that was the 13,000 period. So there are 14 lines of evidence if you throw them all in. And the question is, you know, are they impact related? And this was argued out with those bastards, the critics. Was it impact related, or was it just a normal rain of meteoritic dust? Because there are 50 tons of stuff coming in every day, mostly very, very small. And a lot of that stuff is going to ablate to a shooting star leaves spherules, right? But you're just not going to have a whole hell of a lot of them. So it's reasonable to, you know, these guys are assholes, but it's a reasonable question from assholes, right? Was it just a normal rain? Okay, well, let's look at the spherules. So we found them at 13 of 15 sites, right? At 56,000 times what would be expected in the background soils. So if it's hard to find the spherules in the first place in that fraction, and it's fairly hard, you got to sort it pretty hard, it would be very hard to find them in just regular strata, right? So you find 56,000 times more. Iridium, and you know, it's too much to change this slide, but now it's platinum. Iridium's squirrely. Iridium was helpful. Iridium's, people know it from the KT boundary, but it's expensive as hell to test, right? And it could be squirrely because of this thing called the nugget effect. And then platinum is now our geochemical marker. And we find that in the same kinds of wild concentrations, okay? So iridium and platinum found at 10 of 13 sites at 6,000 times what would be expected. And I think that's much higher than the KT abundance. Carbon spherules, 18 of 22, 14,000 times what you would think you would find normal soils. Nanodiamonds, found it at every single one. We've got more sites now, that's a little dated, at 20,000 times as much as you would expect. So you take this evidence, and this slide's fucked up, which is fine. Had some heat map stuff on it, and we lost it yesterday when we were playing around trying to fix these animations. But what it indicated is if you go out and graph the abundance of this stuff, you're going to have a hell of a lot less of it in Arizona, even though it's abundant, than you're going to find in Gainey, Michigan, right? Or Shabbat in Canada, or these Lake Hind, right? Those sites that were closer to the ice sheet have much more material in them, which suggested, and that's now been a legacy understanding of the hypothesis, that something happened over the ice sheet. Okay, let's talk about the extinctions, because that's, again, where we're in that wild mystery, where the mainstream certainly accepts there were extinctions. It took a while. You know, they've argued about that for 150 years, right? Randall, I mean, the fact that a species could go extinct, one believed to be the case, but in the 20th century, we certainly accepted it. And we came to understand that 250 species went extinct, right? And so you've got some, you know, the general answers for that, the possible explanations, I guess you would call it, for how in the hell that happened, if you ask a mainstream scientist. And they fall into camps. The camps are human overkill, that we did it, that climate change alone did it, that disease did it, and that's kind of a boutique theory, but worth saying, that they had a very bad COVID virus that infected mammoths and glyptodons and whatnot. And we think we kind of made it now to, I've seen it in books where the others are discussed by mainstream guys and they'll throw us in and trash us, but in the YD impact, right? Let's talk about the overkill theory, because that's just an obnoxiously stupid assumption. And anyone who's ever hunted or even thought deeply about hunting knows that, you know, we do extinct animals, and we do it through habitat loss mostly. It's not that we go and hunt down the last Carolina parakeet. We go cut down all the cypress trees, right? Although hunting is sometimes involved. And it does seem plausible because, damn it, we do cause extinctions. There's just no doubt about it. And when this theory or approach was first proposed, it was in the late 60s, and we were just kind of developing our environmental consciousness and taking, note that we were making species go extinct left and right. And that's a good thing to know that. But of course, the politics and ideology of it thought it was very handy to say, you know what, and we're so bad that humans are such nasty, destructive creatures that not only are we killing species now, but we've wiped out all these other ones. That we were just such rapacious hunters that we were able to do this. Now, it's ridiculous on its face. We'll get to that in a second. But I guess it can't be ridiculous on its face and plausible, but it does seem plausible because we caused extinctions, okay? And the idea would be that through one of three routes or three of three routes or whatever we say, and we all know there were pre-Clovis, but we all know Clovis were the first distinct, easily acknowledged, we know they were there, culture in North America, that they came down into a virgin continent and that they encountered animals that had never seen humans, except perhaps a little bit of pre-Clovis people maybe. But if you take the view that they encountered witless animals, they could have hunted them very easily. Kind of makes sense. Kind of wonder who hunted the last glyptodon, which is an armadillo the size of a golf cart. Because to this day, no one eats armadillos. The hungriest man in Mexico does not eat an armadillo, right? So why the hell would you hunt the last golf cart armadillo down to eat? It's just, But there are other reasons to explain. And the way to frame it, because we know that the Clovis people were involved in killing mammoths. But were they responsible for 100% of the loss of all those species, or did they get 5%? I think they got 0% of the glyptodon because people just don't eat glyptodons, okay? But mammoths and stuff, yeah, we probably contributed that, and maybe after the destruction, maybe we picked off the surviving people could have picked off some of the last ones. But here's what the problem is with that. In Asia, man, they've been hunting megafauna for millennia, for 40,000 fucking years. They've been hunting mammoths. They've been hunting elephants in Africa through all of recorded time. It's an insult to those people that we think only here were we able to hunt all those things down, right? And there's actually some, good quantifiable evidence. So they were familiar with man, and they could run from us, but they went extinct too, right? Okay, there's kind of a graph showing how they petered out. So that's like, this is in Siberia. So you see some remain after. They tail away. Horse, that species that went extinct. And then bison. But let's look. That's where all the dated mammoth sites are in Russia and basically the Siberian side of Russia. Okay, so those are well-dated mammoth sites. Let's look at where they find paleo people. So yeah, there were mammoths associated with paleo people down there. Maybe that could be a place they could hunt them down. But there are no paleo people up here. There's one paleo campsite that they found up there. They just didn't really live up there. And there were a hell of a lot of mammoths. So who the hell went and killed the last one there? You know? Okay, so humans likely contributed to extinctions. I'll give them that. But could we have been the only cause? Okay, close that one. What about climate? Some people think it's the climate change. And again, that's well accepted science, kind of like it's well accepted that we cause extinctions. So the climate change theory claims that as the Younger Dryas began, the return to near glacial temperatures killed the animals. Okay, and the Younger Dryas, it was very, very dramatic. See how it drops there? The damnedest thing's how we come out of it. Very little done on that, and we don't do anything on it, but it's a great question because it was an Easter day like no other Easter day, man. the whole earth in the period of 10 years just came back. There should be a movie on that. I mean, it'd just be the greatest movie to have the bad part, then the miserable 1,000 years, and then you come out of it, you know? What a wonderful story. So according to, you know, ice core data, 12,900 years ago, see varying things, but let's say it's 18, 20 degrees Fahrenheit that temperatures collapsed near instantly. And what would animals normally do in that case? If there's nothing completely catastrophic and it just got 20 degrees colder, I'd turn south, right? You'd migrate. Their natural thing, not that they know it's warmer to the south, but animals do migrate in response to climate change. It's very, very well accepted, obviously. And that's the typical solution. You know, that's what normally would say, but we ignore it in this case. They say somehow just because it got that cold, all those animals died. Okay, here's the problem with that. This Antarctic ice cores showing the last 400,000 years, and these graphs go confusingly in reverse to what you would think. This is older. No, this one's, no, that's the way your head does it. Yeah, this one's older. Those are temperature swings. Look how dramatic they are. Each past ice age was a long cooling followed by a brief warming. And they're all about 100,000 years wide. Isn't that wild? You know? 100,000 years. And then ice ages. These were called ice ages, right, Randall? Or these, the tips of the ice ages. Then, you know, you're varying around. Okay? But no previous extinctions, right? It was just as wild. Some of those dips and drips, when you go back into deeper time like that, were probably as dramatic as the Younger Dryas. But it never caused the extinctions. Only 13,000 years ago did we see those extinctions. So we don't think extinctions were caused by climate change, per se. We think it was an impact event that was the cause. It's not the only factor, but a major one in the extinctions. They were killed by massive explosions, intense firestorms, habitat destruction. I think that's the most important, because you turn it into that wasteland, you know they're tipping points for species. And that's a hell of a tipping point from a habitat perspective. And even if there were pockets of refugia, as they call them, and there were, mammoths persisted up until 4,000 years ago on Wrangel Island, right? So they took them out, toxic chemicals. There's some chemistry that's kind of beyond me that says in these interactions, et cetera and so forth, you can end up with, and probably do end up, they've even found a tusk that shows it with intense acid rains for years and years. That's not going to help a species. And sudden climate change. The cold certainly doesn't help. But you take all that together, right, and that's going to affect animals and plants. But what about humans? You know, that's the cool thing about the Younger Dryas theory relative to the comet and the dinosaurs, which is pretty interesting in its own, and I was interested in it as a kid and whatnot. But damn it, that was 65 million years ago. That might as well be on another planet, in a sense. A planet we know really well, but it's just not us. It's a different world, the dinosaurs. And I'll give you this fact, that the Younger Dryas event at 13,000 years, I believe it's 3,500 times more recently. So if you put a timeline from my house, you know, being the current age, and pull it all the way out on I-40 to Barstow, California, and say that that was when the dinosaurs are, and all the years between that 65 million are contained in that 3,000 mile long timeline, 3,500 mile long timeline, right? The Younger Dryas event happened at the 7-Eleven 5 blocks from my house, right? It's 3,500. That's 1 mile of that 3,000 miles. So that's what makes it so much more interesting. You know, it's right temporally associated with us in a geological sense, and we watched it happen, right? So how do we know, come on now. We've got some evidence that it wasn't a good day for people, okay? Obviously we survived, but our Clovis points, Al Goodyear cataloged all the Clovis finds in South Carolina, and they have that distribution in abundance. And then the follow-up lithic technology was called the redstone. Somewhat similar, y'all get that, savvy crowd on this stuff. They change technologies. And look how many fewer of them there are. And these should have been really successful people if they just hunted all these mammals down and whatnot. Why would there suddenly be less of them? And why would they change their technology? We think they changed their technology because they, it took 1,000 years to kind of recover, and get any kind of normal life way back together and start making they probably said, we're just not going to make the point the same way. Things have it's been a bad 1,000 years. We need to pick up a new technology here. Just don't even want to think about those times. So they started making the redstones, and a lot fewer of them. Okay. Clovis points to redstones. That's them dropping. That's Virginia, South Carolina, North Carolina. Relative abundance when you go to the redstones. Again, shows a dramatic drop. And we're inferring population from that. It could be you had the same population, but they just were much better atlatl hunters and used fewer stones, but probably not. Stones are a good proxy, or points are a good proxy for population, probably. Oh, just said it's probably a decline of like 60 or 80% that our guys estimate. So 20% of us survive. And you can see it out west too, in the transition from Clovis to Folsom. The Clovis points were tremendously abundant, and then you don't find as many Folsom points for many, many hundreds of years afterwards. Roughly 50% population decline indicated by that. Okay, let's talk about the impactor. What kind of cosmic object could produce all this damn evidence but left no visible craters, no melted impact rocks like you would see that used to lay on the side of the crater in Winslow, the Barringer crater up the street, right? They actually find big old hunks of iron laying around. Left debris across 4 continents. So what kind of thing would cause that? And this is important, and this is where people who are, God bless them, kind of into the theory, and actually kind of took me a while to get it. I had to talk to Bill Napier, the guy who came up with the whole idea separate from the YD thing, that the important thing about comet impacts is it's not a comet. It's not a coherent comet that we're worried about. Now, it'd be a very bad day if we happen to get hit by a coherent, intact comet. In fact, it would be like the dinosaur extinction. It would be much larger. It'd be very traumatic. Okay, but what we think it was a comet that was already well into its disintegration, which you call hierarchical disintegration, where it goes into 2 pieces, maybe one big and one a third smaller, then that one goes into 2, and hierarchy all the way down. But each piece is not doing it at the same pattern. So after you go through enough hierarchical disintegration, you end up with a bunch of big pieces, medium pieces, small pieces, and many, many more tiny pieces, with fewer big pieces all the way down to many, many more small pieces, coming in a swarm that develops a meteor stream. And what we speculate, and there's actually some pretty hard science on it, where they've kind of reverse engineered the Taurid meteor complex. And the neo-catastrophist astronomers, who are great men, they're all in their 80s now, but man, they fought it out through the 70s and the 80s, saying, it's not asteroids ain't the problem, it's disintegrating comets. And you guys are out there looking for asteroids, that wayward asteroids, and you're gonna find a lot of them, and some of them could hit, and you could have an asteroid impact. But what causes what we believe are these repeated traumas to the Earth during human times, and this was Klube and Napier saying this, it's hugely controversial, was that we're not talking about that. We're talking about, we think, in this instance, that 20,000 years ago, so 7,000 years before the YD impact, that a 60-mile wide comet entered Earth's solar system, just like this one called BB is coming in now, called Bertini-Bonelli. We've got one out there that's like 100 miles, and it's starting to disintegrate. Okay, but here's one that they've studied over recently, that it came into the solar system, it began disintegrating, And 7,000 years later, we hit a really, really bad patch of it because the streams aren't the place where you enter the stream, which happens twice a year at the end of June. June 30th, Tunguska was a tarred object, right? That's why it's on June 30th. That's not a coincidence. That's when you go out. You can go out on June 30th right now and watch a meteor shower that caused the Tunguska incident, my belief. And then it happens again in late October, early November. And Randall has a fantastic presentation on the connection to that and Halloween. Right? Because it turns out every culture that celebrates a week of death, and a hell of a lot of them do all around the world, pre-contact cultures, celebrate that same week as the week of death, and we're still out there knocking on doors with scary masks. It's still reverberating through our culture, the trauma that we've experienced in late October and early November. Not just at the YD, but we think probably 4 times since then, because all the tree rings stopped. All the trees stopped growing on Earth 4 different times after the YD event. So let's get to the Schwassman-Wachman. And this is kind of timely too, because this damn thing they just reported, I'm not sure how exactly they know it, but it was minor science news a couple of weeks ago. It might be big science news if it happens. But on May 30th, we're going to encounter a part of this stream, which is much more recently. It's just been disintegrating for, I don't know, 50 years or something. But we're going to encounter a bad part of it, and it could be the most amazing meteor display we've ever seen for, like, I think they said 3 hours. For some reason, it's a short one, doesn't go on for a couple of days. Maybe that's because I don't know. But it's supposed to be May 30th, so put that on your calendars. Who knows, might be a bad day, right? Okay, so this one, this is an old slide, it's probably grown. So if you took the width of the stream of material, it'd be about 1/3 the size of the US, have more than 100 major fragments. It'd yield 100 large airbursts if we encountered it. A total mass of maybe 4 kilometers. But remember what I said, the one that we believe came in was probably, we estimate, 60 kilometers. So it's much bigger, and then it had 7,000 years to disintegrate. So it was still chunky monkey with big pieces in it, right? But it was spread out much more widely. And here's kind of the spooky thing. When they do impact frequency estimates for asteroids and sometimes comets, they only view it as the pinpoint of the comet. What is the chance of that pinpoint of one coherent comet hitting the Earth? It is very, very fucking small. Might have happened on the dinosaur thing. There might have been just 2 fragments then, because it's suspected there's an Indian crater that happened that same day. But point is that there's a shotgun. We're getting hit by shotgun pellets, not rifle pellets. Now, what's a better shot? A shotgun, a guy with a shotgun, or a guy with a rifle? A guy with a shotgun's always a better shot. He stands a better chance of getting that bird. Nobody hunts ducks with rifles, right? Because the best way to hit something is to spray it. And what we're doing is we're encountering the spray, and the spray waxes and wanes in its degree of large material. Bill Napier, the father of this stuff, he's a wonderful Brit. He described it to me as it's like we're putting a blindfold on twice a year and walking across a highway, right? Now, at a random time during the day. Now, a random time during the day, frankly, you'd be okay most of the time. It might be scary. Sometimes it'd be just fine. 3 o'clock in the morning, you could turn around and walk back, you know, and you wouldn't get hit. And then, but sometimes you're going to come across that highway and it's going to be 4 o'clock pre-jam traffic, and there are going to be a bunch of damn trucks mixed in with the small cars, right? And that's what's going on. That when we cross that highway, we do it safely many more times than the times we encountered. But every time we see the little cars, we do get the shooting stars every time, but they're chunky parts of it, right? So that's what we think's going on, is that it's a disintegrating comet. And like Rogan kind of needs to know that sometimes. See, I think too many people think that when we, even if they get the disintegrating part, and Mark Boslow, for God's sakes, our biggest antagonist, and he knows we don't think this, he did detailed, not too detailed, but tried to undermine the hypothesis by saying, the comet could not fragment in the 60-mile depth of the atmosphere. And we're like, no shit, that's not what we're saying, man. The damn Klube and Napier have been saying since the 70s that it's already out there fragmenting and we're hitting the shower of it. And he's sitting there going, see how stupid they are? They think a comet came in and somehow it managed to disintegrate, going 70,000 miles an hour in 60 miles, turn into a bunch of pieces and spread all over the northern hemisphere. Yeah, that is ridiculous, dude, but that's not what we said. So numerous fragments of a comet, dust size to 2 kilometers, don't want to see that day. Ice craters. You know, if this was concentrated in the northern hemisphere, if anything hits the ice sheet, you're not going to see anything but a remnant. You're not going to see a typical crater. And I liken that to, you know, you drop a really heavy object off a bridge, right? If there were no water down there, it'd leave a crater in the mud, right? But if you have a different density below you and between you, you drop it down, it hits that different density, and it explodes, right? In a sense, in the water, a big splash, big kinetic, you know, release. But then the brick, it doesn't make a crater, right? So when you hit that ice, first of all, that applies to airbursts. It applies twice. That you're coming in, you have explosions in the atmosphere that don't make it all the way down, and the ones that got enough oomph to make it all the way down, that make it to the ice, they hit the ice, and then that's another thing going on where you're going to destroy the ice, but you're probably not going to leave a typical crater in the bottom. So we think there could have been some big impacts in Canada, and we probably think they're missing impacts out there. And they're probably misattributed craters that are younger, and we haven't found that out yet. Would have caused intense continental firestorms. Estimate that 10% of the Earth was lit on fire immediately. And that's actually higher than the dinosaur KT thing, believe it or not. You'd think it'd be 90% of the Earth, but it wasn't. I guess 10% of the Earth catching on fire is big enough. But supposedly, the soot evidence shows, and we got the best soot lady in the world, right? Wendy Wolbach at Purdue. And she did done plenty of work on the KT boundary soot. She knows that whole story. She goes and looks at the soot from this, and we did a full paper on it about the global firestorm because they were coming out saying that it was climate change, that you have more fires when it got colder in the Younger Dryas, and that's why we see fire signals all over the world 13,000 years ago. And they did very complex statistical analysis, had to come back and say, no, when you really look at it, there's a lot more fire at that time than there should be, even if we had set the climate change fire connection. High temperature shock waves, right? Legacy slide. And then I'll close with, that's my website, right? And I started that because in 2010, when the paper came out in 2007, we kind of had a honeymoon period. And it was great. You're like, hell yeah, I was on this scientific paper, and now it's, going to be a big thing, and it's getting reported, and there's going to be TV, And so the media was kind of good and whatnot. And we started going to the conferences. They're a little rough. By 2010, we went to the AMQA, the American Quaternary Association conference, in Laramie, Wyoming. And that's a fairly small community, but it's a big subject, and they had all the main people in there, including Todd Servo, Randall, and other names and paleo stuff. And they just treated us like mean girls, man. It was awful. Wouldn't talk to you in the hall, no coffee out, and let's go through this stuff and see whether we can find some common agreements. Just snickers and snorts of derision in the flesh. And it was so painful. And I'll actually give you, I hope I'm not going on too long because you can see it's wrapping up, but I'll give you a little story about that guy, Todd Servo, who's in a way, you'd see him from the internet. I kind of like him in a way. He's got a good job, and he's studying the right stuff. He, unfortunately, is the last proponent, probably one of the last proponents of overkill. He still sticks to the party line that we killed all the animals. But Todd isn't a terribly bad guy. But he went and tried to test our hypothesis by looking for the spherules. And so he went out, got some of the material, and then was going to see whether he could find spherules. Well, first of all, that's not really his gig. You know, he's a paleoanthropologist, archaeologist. He doesn't do, you know, material science. You know, so what he did, first of all, he didn't sift it correctly. And it kind of sounds rinky-dink to say he didn't follow the protocol, because some people, they're wrong about their beliefs, and then somebody undermines them. It's sometimes to go, they didn't do it right. But damn it, he didn't do it right. He didn't size sort it. He was looking for golf balls in a bucket of beach balls. And he didn't strip out all the beach balls. And you've got to keep finding, and it's a laborious process. We would test more sites if we could, but it literally takes hours and hours and hours to get it all sifted down to that finest fraction. But then the fraction that he did find, he didn't use a transmission electron microscope. He used an optical microscope. So that's like refuting an astronomer's data by using a hand eyeglass instead of the fucking Hubble Space Telescope, man. You don't use the same equipment, you know? And then he published a paper that was devastating to us. It's devastating, still out there. Oh, they didn't find those spherules. That group was undermined a long time ago. Todd didn't find those spherules. If they know the name, most people wouldn't know his name. They'll know just enough about it. They didn't find them. So it's devastating. But that was right.